Welcome to Fix It Friday, and this week we're looking at apparatus diagrams, in particular in relation to organic chemistry. So two diagrams we should always be able to draw are reflux and distillation. So the question is asking for a diagram of the apparatus used to prepare ethanol, which is an aldehyde, from ethanol. So distillation is the correct apparatus to be drawing. So that's one of the things that's good about this diagram, that we've chosen the right apparatus. It's surprising how often we actually draw the wrong one. And then reagents and conditions have been asked for as well. So are there any other good things about this? Well, we've got a round flask with contents. So that's a strange thing to say maybe. But it's also quite frequent that students will just forget to just draw that little line in their flask that actually shows that there is a reaction mixture in there, and they're drawing empty flasks. You can draw a round flask or a pear-shaped flask or some sort of weird thing that's sort of halfway in between if you're not very good at drawing. We don't want to draw a conical flask because we're meant to be distributing the heat. So the flask with contents is good. The thermometer is good, and the thermometer is placed in the correct place for distillation, which is just before the entrance to the condenser. And also we have no gaps in our apparatus, so our liquid can go upwards. So let's have a look at the problems. Well, one of the first problems is, although we have no gaps in our apparatus, so the gas isn't going to escape, it also cannot enter the condenser because we've got these two parts where we've sealed off the ends. So the ends of the condenser, the gas can't actually go through, can't condense, and can't go into liquids. Remember that our diagrams are always cross-sectional, so we should not have any gaps where things can get out from the sides, but we also need to make sure that that gas can follow all the way through to the collection container at the end. Okay, what else is the problem? Well, we talked about a round bottom flask or a pear-shaped flask being important to distribute heat. The source of heat has not been drawn, or there's been no reference to heat in this diagram. So reference to heat can be as simple as an arrow underneath with the word heat. There is no requirement to draw a Bunsen burner. In fact, it's not good practice to use a Bunsen burner for this because aldehydes and alcohols are extremely flammable. So probably we would rather have a water bath or an electric heater, but you don't really need to be able to draw those. So you can just simply do an arrow and the word heat, but it needs to be in there because it's part of the experimental setup. Okay, now let's have a look at our condenser. Another common problem, so they realise that they have to label the water in and water out, but they are the wrong way round. So water goes in at the lowest point of the condenser. So in this case, that is the point on the right hand side. So we want the water to flow against gravity so that we can maintain a good pressure in the condenser, keep the cold water flowing around, and therefore keep condensing the liquid really well. And so our water should be in at the bottom of the condenser, not at the top. And then finally, it doesn't really matter about having a collection container. You can draw little drops going into it if you want. Actually, that's not an essential part usually. But the second part of this question asks for reagents and conditions. So very tricky one to spot, easy mistake to make. So if you are going to use formulae, make sure you know the formula very well, because dichromate ions have a 2- charge, which you would know if you remembered the formula, for example, for sodium dichromate, Na2Cr2O7, 2 NAs because the dichromate has a -2, or you could have K2Cr2O7, or there is nothing wrong with simply writing dichromate. Watch out for a question that asks you to name the reagent or give the reagents, in which case we should also try to avoid simply writing ions, but we should give full names like sodium dichromate. H plus probably would get away with it in this question. If you're asked to name the acid, so again, you can usually write acidified instead of H plus, then the acid needs to be sulfuric at a push nitric, not HCl. And that is because HCl provides chloride ions. Chloride ions can themselves be oxidized by dichromate to make chlorine. And then they've just one more time just completely shot themselves in the foot. They've drawn the correct diagram for distillation, but because you just get into a habit, we've got the word reflux, which is a completely different setup, with the condenser being vertical above the flask. And if I refluxed that reaction, I wouldn't make ethanol, I would make ethanoic acid. So make sure you don't go into autopilot and start including things that you write loads of times for reaction conditions. Just because you write them lots doesn't mean you write them all the time.